Hello everyone. So today we are going to see the topic of our Thomas Fermi model of the atom. So in Thomas Fermi model, electrons are considered as a gas obeying the Fermi-Dirac statistic. So since they obey the Fermi-Dirac statistics, they are considered as a fermions. Here, the potential V of R is assumed to be the slowly varying. So the many electrons are localized within a volume over which the potential is almost a constant. So if so they have given that potential V of R is assumed to be slowly varying. So if it is slowly varying, the many electrons are localized within the volume which whose potential is almost a constant since they are slowly varying one. So as electrons are treated as a fermion, we can apply the concept of cells in a phase space to the states of an individual electrons. So using that concept, the volume of the phase space is equal to 4 by 3 pi p cube into dV. So here the number of cells or states, the number of states can be given by 2 into the volume of a phase space. So we are taking the two states. So 2 into 4 by 3 pi p cube dV divided by h cube. If all the states to be occupied, assumed to be occupied by the electrons, that is the in the above given cells or states, if the all electrons are assumed to be occupied in those cells, number of electrons per unit volume nr can be given by 8 pi by 3 divided by 3 h cube. Simply dividing by dV in the above equation, we will arrive with the number of electrons per unit volume n of r can be given by 8 pi by 3 divided by 3 h cube. So here we know the value for h, right? The h can be, we know that h cross is equal to h by 2 pi. So the value of h can be easily obtained as h cross into 2 pi. So I can substitute the value of h cross into 2 pi in the above equation, that is n of r equal to 8 pi. That is in this equation n of r is equal to 8 pi by 3 divided by 3 h cube. So I am substituting the value of h cross by 2 pi. So what I will be arriving is n of r is equal to 8 pi p cube divided by 3 h cross cube into 2 pi cube. So we can cancel the 8 pi and 8 pi in the numerator and denominator, and the pi cube will get cancelled and the remaining pi square will be in denominator. So taking this as the equation 2, which gives the number of electrons. So now we have to look for the value of p, right? So p is nothing but a momentum. So if the maximum allowed kinetic energy at any distance r is minus vr, that is we can give it as p square divided by 2m equal to minus v of r. So the p square value will become minus 2m into v of r. So what I need is only the value of p. Here I have the value for p square equal to minus 2m into v of r. I'm going to get the value of p alone. So the square on going to the right hand side will become the square root of minus 2m into v of r. So I have got the value of p. I'm going to substitute in the above equation, which is nothing but n0 equal to p divided by 3h cross cube divided by pi cube. So the above equation will become like on the right hand side minus 2m v of r the whole power 3 by 2 divided by 3 h cross cube into pi square become less. Here the electrostatic potential minus v of r divided by E and the charge density minus E into n of r obeys the Poisson's equation. So we can write it as 1 by E into del square v of r equal to minus pi E n of r. On taking the 1 by 3 to the right hand side, it will be E will become E square, and the term on right hand side is minus 4 pi E square into n of r. Here the potential is spherically symmetric since the nucleus is at origin. So we can write the del square V value as 1 by r square d by dr into r square dv by dr. So here also I have the value for del square Vr, and from the Poisson's equation here also I have the value for del square V of r. So I can equate this equation 4 and 5 On equating the equation 4 and 5, we will be arriving with this term of 1 by r square into d by dr of r square into dv by dr equal to minus 4 pi e square into n r. So here if we look into the equation on the right hand side, n of r is nothing but the number of electrons, which we know the value for it. We have already derived an equation for n of r, which is nothing but the value of minus 2m v of r whole power 3 by 2 divided by 3 pi square h cross cube. I'm substituting the value, so the right hand side will become like this. So when r is equal to 0, the potential is due to the nucleus. So the potential due to the nucleus can be written as v of r equal to minus z e square divided by r. We are introducing the function chi of r defined by v of r equal to v of r is equal to minus z e square chi of r divided by r. So I'm going to substitute this value of v of r in the above equation. 1 by r square d by dr into r square d by dr into minus z e square by r chi of r equal to minus 4 e square divided by 3 pi h cross cube into minus 2m into the minus z e square chi of r divided by r whole power 3 by 2. So we are here how we are going to solve means we are first I'm going to consider the left hand side and then I'm going to solve for the right hand side. So let us solve the terms in the left hand side. As we can see, there is a two differentiation terms in left hand side. The one is outside the bracket and the one is inside the bracket. Here how we are going to solve the equation is, first I am going to differentiate the term inside the bracket and then differentiate the resulted term with the outside differentiation. So we have already substituted the value of v of r, which is nothing but minus z e square divided by r into chi of r. Here minus z e square is a constant term. It is not going to vary with the respect to r, so I can take it outside and as minus z e square divided by r square. So the only terms I'm within the brackets here now is r square into dr d by dr of chi of r divided by r. I'm taking the r in the denominator to the numerator. So here now there is a two term chi of r and r inverse, both are varying with respect to r. So what I can do is simply differentiating them with respect to the uv concept. We know that differentiating uv we will do in the form as uv dash plus v into u dash. So first I'm going to differentiate the r inverse term. On differentiating the r inverse term, we will be deriving minus r power minus 2 into chi of r plus r inverse and keeping r inverse as a constant. On differentiating chi of r, we get r inverse chi of d chi of r divided by dr. Here I have r square outside the bracket. I'm simply going to multiply this r square in both the term. On multiplying with the first term, the r square and the r power minus 2 will get cancelled, and in the second term we have r square and r inverse. On cancelling we will having only the r into d chi of r divided by dr in for the second term. So the terms inside the bracket is minus chi of r plus r into d chi of r divided by dr. Now I am going to differentiate these terms with respect to dr again. So here I will be getting the three terms as a result of first term we have one term from the chi of r differentiating. So in second term we have a uv format. So I am going to differentiate in terms of uv form. So I will be getting the two terms. So totally there are three terms I am going to get. I'm going to differentiate the two terms. On differentiating the first term minus chi of r, we will get like minus d chi of r divided by dr. So the second term, which is in uv format, I'm going to differentiate with respect to in the form of uv as we have done in the above step. So I'm going to first differentiate the r. So dr by dr into d chi of r by dr, I'm keeping it as constant. And then the next term I'm going to keep r as constant and differentiate d chi of r divided by dr. So r into d square chi of r divided by dr square. So here if you look carefully, here this dr by dr will be 1. So what I will be having is minus d chi of r by dr plus d chi of r by dr. So I am simply cancelling these two terms. The remaining term, the only remaining term I will be having is this term, r d square chi of r divided by dr square. So on simplifying the left hand side, the term we will be having is minus z e square divided by r into d square chi of r divided by dr square. Now consider the right hand side term. In right hand side term we are having this term. So first what I'm going to do is nothing, we are just going to separate the terms inside the 3 by 2. As you can see, there is a minus sign for a minus 2m and minus z e square. So this minus and minus will become plus. So next step what I'm going to do is, so what I'm going to do now is I'm going to simply apply this 3 by 2, power 3 by 2 to all the terms inside the bracket and writing them separately. As a result, we can write it as 2m power 3 by 2, z power 3 by 2, e square 3 by 2 and chi of r 3 by 2 divided by r power 3 by 2. Here this r square and 3 by 2, the 2 in the denominator will get cancelled and we will be getting the e power e cube, and the remaining terms will be as such. So we have simplified the right hand side. Now equating the results of both the left hand side and right hand side, we are having this result. So here we are going to cancel some terms. So here e square is common in both RHS and LHS, so we can cancel out this e square. And here we have z term and we have z power 3 by 2. Similarly we have r in denominator on left hand side and also r power 3 by 2 in right hand side. So considering the powers of r and z, we can write it like the denominator r go to the numerator of the right hand side and the z which is the numerator on left hand side will go to the denominator on right hand side, like this. So on considering the powers of r, if it comes to denominator, the power will be 3 by 2 minus 1, we get r power 1 by 2. Similarly the powers of z will be transformed to 1 by 2. So now we have got the value for d square chi of r divided by dr square equal to 4 e cube 2 power 2m power 3 by 2 z power 1 by 2. Sorry, it is z power 1 by 2 there. Mistakenly written as z power 3 by 2. It's 1 by 2. Z power 1 by 2. Chi of r 3 by 2 divided by 3 pi h cube r power 1 by 2. Now we can express this above equation in a dimensionless form by r is equal by substituting the value for r as bx, where b is a constant one. So we can write it as d square. I'm going to substitute. The equation will become d square chi of r divided by b square into dx square. In right hand side, in denominator, if we substitute for r, it will become b power 1 by 2 and x power 1 by 2. On simplifying, if this b square goes to right hand side, it will go to numerator, and here that is also a b power 1 by 2 in denominator. If it comes to numerator, we will get this term b power 2 minus 1 by 2, which is nothing but b power 3 by 2, b power 3 by 2. So as we have already seen that b is nothing but a constant, so I'm going to choose a value for the b such that in a way that the coefficient of psi power 3 by 2 and x power 1 by 2 is 1. That is this the coefficient of this particular fraction to be unity. In order to satisfy that condition, the value of b can be taken as 1 by 2 into 3 pi by 4 whole power 2 by 3 into h cross square divided by m e square into 1 by x z power 1 by 3. So if we substitute this value of b in above equation, the above equation will become like d square chi of r divided by dr square equal to chi power 3 by 2 divided by x power 1 by 2. This is nothing but a dimensionless Thomas Fermi model equation. Thank you.